Hi, Andrea. It's Miss Lorenz here. I'm going to go ahead and do two of these problems for you of turning these repeating decimals into fractions. And then if this explanation is still making things confusing for you, or if you're still a little bit confused, then we can do a Google Meet and we can do some together. So I will tell you that this first section for 8th grade math is, oh my gosh, it's so hard for everybody. So please, please, please don't feel bad about that. Just realize like everybody's like, what are we supposed to do? All right, I'm going to do this one, just kind of walking you through it, and then we'll go ahead and do this one. Notice, actually, let's make this one even harder. So we'll do, this one has a whole number and a repeating decimal with two different digits, and then this one has just a repeating decimal. So what we're going to do is we're going to say that x is equal to that repeating decimal, or to what we start with. And what we're doing that so that we can, what we essentially want to do is we want to remove the repeating decimal from like not having to deal with it. So the way that we can move things so we don't have to deal with this repeating decimal is we can multiply everything by 10. So I'm going to multiply by 10 over here, and I get 10x. Now when I multiply by 10 over here, when we multiply it by 10, we essentially move the decimal place 1 to the right. And so when I do that, I end up with 4, and then 4/10 repeating, because this would go on forever, right? You could even write a few of them out just to like remind yourself that that goes forever. Now, like I said before, we want to get rid of this repeating. So what I'm going to do is I'm going to subtract that. I'm going to subtract all the repeating 4s. So think of it this way. If you have infinite 4s and you subtract infinite 4s, you've eliminated all of those infinite 4s. So now what I have is just 4 over on this side. But the rule, of course, is if I subtract infinite 4s over here, then I have to subtract the infinite 4s over here. But look up here. What was the name we gave to infinite 4s? The name we gave to infinite 4s is x. So I'm going to subtract an x over here because it's the same thing. An x is the same thing as the infinite 4s. And so if I can just say x over here, then I can basically speak the same language on this side. So 10 x's minus an x, that's like 10 apples minus 1 apple. So I end up with 9 x's over here equals 4. I'm trying to get x by itself so I can figure out what it's equal to as a fraction. So I'm going to divide by 9. And what I'm left with is 9 divided by 9, as you know, is 1. So I'm just left with a plain old x equals 4/9. So now I know that 4/9 is equal to x, and it's also equal to, right here, 0.4 repeating. So I've given it a new name, and its name is a fraction. Okay, let's do one here. I don't know, I just made this up, Andrea, so I don't know how well it's going to work out, but we're going to give it a good shot. So we're going to do the same thing we did before. We're going to multiply by 10. So I end up with 10x over on the left side, and then when I multiply by 10 over on the right side, I end up with 15. And remember, the 5, 3 is repeating, so I'm going to have a 3, 5, 3, 5, 3, right? Keep going like this. I'm going to do the same thing. I'm going to subtract from both sides my x. So I'm going to subtract here an x, and I end up with 9x. And then over here, I'm going to subtract an x, but this time I'm going to subtract what the x is equal to, which is 1 and 53/100ths. But remember, that's repeating, so I can go 5, 3. I don't actually need all these digits out here. I just wanted you to remember that those were repeating. So let's just stop right here. And then we subtract. So I'm going to make that a 13 and that a 4. So then I end up with 13.818. You can probably imagine what this next one is going to be because this pattern is going to continue. 181818. And that equals 9x. So then I'm going to divide both sides by 9. Of course, 9 divided by 9 is 1, so I'm left with x equals this really ugly fraction. Like, isn't that super ugly? That's technically the answer, but it's not proper to have a decimal in a fraction. So to get rid of this decimal, we would have to move the decimal 3 places to the right. Or in other words, we would have to multiply by 1,000. So we end up with 13,818 over, we also have to multiply the 9 by 1,000, 9,000. And when we do that on the calculator, so that's the fraction, and you're probably thinking, whoa, Miss Lorenz, that is crazy. And it is crazy. But now when we do this on a calculator, 13,818 divided by 9,000, we're going to get 1. Look at what we got, the same thing that we started with. 1 and 53 repeating. And so 53, 53, it should say 53, but the only reason it doesn't is because we didn't go like right here. The further out we would go here, 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 and the further out these would show that decimal. Okay? So that is the answer. 13,818 divided by 9,000, or 13,818 9,000ths. Now you could turn that into a mixed number. That's going to be 1 and, so I'm going to do 13,818 minus 9,000, because I know 9,000 will go into that once. So we could say that is equal to 1 and 4,818 9,000ths. I could divide both of those by 2. 1 and 2,409 4500ths. And that's as far as I want to go right now. Remember, this problem that we just did right here is one that I just made up, so these numbers are kind of extra ugly. You shouldn't run into quite such big numbers. But Andrea, let me know if this helps, and if not, we'll have a meeting. Another one. Thanks, dear.